Views of a function. In this problem, it says create a table of at least 5 different points. So somewhere over here on the right side of con, they have some kind of a table with little boxes for you to insert the numbers. All you're doing is an input-output table. So continuing to use this is my x values, this is my y values. My x values, most common that students use would be 0, 1, 2, 3, 4. And then what I do is I substitute those in for my variable x, and then I solve for y, which it kind of already is solved for y. So I'll have y is equal to a negative 3 times 0 minus 2, and that will equal 0 minus 2, which would be a negative 2. So when x is 0, y is a negative 2. And that's really all they want you to do it. They just want you to do it 5 times. So in the next one, y is equal to a negative 3. Now I substitute 1 in, minus 2. What is that equal to? Well, a negative 3 times 1 is a negative 3 minus 2, and that is a minus 5. As long as I'm doing my math correctly, this is what will happen. Next one, y is equal to a minus 3 times 2 minus 2. That is equal to a negative 6 minus 2, which is a negative 8. And then I do it with 3. Y is equal to a negative 3 times 3 minus 2. Negative 3 times 3 is a negative 9. Minus 2 is a negative 11. And on number, or not number 4, but on where the x is 4, negative 3, 4 minus 2, that's a negative 12, minus 2 is a negative 14. So you get a negative 14. Now, you can choose any values that you want for x, okay? You can choose any values you want for x. If you want to choose negatives, you can choose negatives. I just chose what I think are the most common from students. Here it says create a table of values for the function in the graph. Use at least 5 different points. All you have to do here is first of all understand that these lines are like roads or streets, okay? And there's an intersection. My blue line needs to cross this intersection perfectly, okay? So right here it crosses there, there, there. Okay, these are the locations that it crosses perfectly at that intersection. All you need to do is choose any of those 5 points. Okay, so this point, we'll go like this, is a negative 4, 9. That would just be one of your points. Again, they have a table over here, and you have to put the numbers in those little squares, okay? You have to choose 5 points. In this problem, there are 1, 2, 3, 4, 5, 6, 7 that you could use. You only need 5. Here we have a similar situation. They're giving you the t-table. It's called a t-table, the xy table. And what you're going to do is move those dots to those locations. So, and it doesn't matter which dot you move to which location, but you need one at a negative 4, 9. So negative 4, 9, one of the dots will have to go there. A negative 1, 0, one will have to go there. 0, 1, one will have to go there. 1, 4, and then 2, 9. And when you fill in all of those dots, all of a sudden a line will show up for you, And you'll see that in the next slide. And there it is. When you get the dots in the right spot, then that line or graph will form. Here is a little trickier. What you're still going to do is choose 5 points. Because I am squaring and multiplying and I got to do all of that in my head, I want to make sure I have an even number so I can do half of it. And I'm going to choose some negatives here. So I'm going to go with -4, -2, 0, 2, 4. Now, again, you can choose 0, 1, 2, 3, 4. Okay, there's nothing wrong with that. I'm just choosing something different. Okay, so when I put in a -4, a -4 squared is 16. So I get 1.5 times 16 minus 3 times a -4 plus 1. Okay, well, 1.5 times 16 is, if I do my math right, 24. Minus 3 times a -4 is plus 12 plus 1. So 24 plus 12 is 36. I get 37. So at a -4, it is 37. Now I put the -2 in. So 1.5 times x squared. X squared would be 4. Minus 3 times a -2 plus 1. 1.5 times 4 is 6. Minus, actually that's going to be plus because a double negative makes positive, plus 6 plus 1, that is 13. When I put a 0 in, this is why 0 is so nice, you're going to get 0 minus 0 plus 1. Answer is 1. Let's see if I can fit one more on here. Let's do 2. Okay, so 1.5 times 2 squared is 4. Minus 3 times 2 plus 1. 1.5 times 4 again is 6. And this is going to be minus 6 plus 1. 6 minus 6 is 0, plus 1 is 1. So I get a 1 here as well. And then you would do 4, and you would end up with your 5 points. The only thing that you need to do in this problem, double check your math. There's a lot of areas for you to make a mistake. And especially if this is your 5th problem, you don't want to make a mistake. All right, next problem. Here again, we just move those points to the location. So the first one, or one of them, it doesn't matter which one, goes to a -2, 2. Another one goes to 0, 3. Another one to 2, 4. Another one to 5, 2. And another one to 8, 4. Okay. Now right away, when you plot the points, you're not going to know exactly what that's going to shape like, but it is going to follow something of a curved pattern like this. Okay. Now here's the hint. When you are given a graph that looks like this, like in the first problem and second problem, and you have to come up with the 5 points, you have to find the 5 locations where the line passes as perfectly as possible. Okay, so let's go to, there's your graph. So you can see here is a point, here's a point, there's a point, there's a point, there's a point, there's a point. You can see all those different points where it crosses as perfectly as possible. Next problem. And here's one of the hard problems. There is other ones out there that are harder, but you have to find spots where it crosses perfectly. Now, some people I know did something like this. there, there, there. So what do we got? 1, 2, 3, 4, 5. So there are your 5 points. Okay? Again, you want to go as close as possible. You don't want to choose points like this, especially if you have other ones that are closer or better. There you go. Good luck.